people. Today we're doing AP Calc review, and turns out I wasn't recording for this first FRQ, so that's pretty cool. But it's pretty neat. I'll talk through it. A. Find the average number of acres. Average number is average value, which this is the average value forming 1 over b minus a times the integral from a to b of c of t dt. And then we just found a and b. A is 0 because that's our initial point, 0, and b is 4 because that's our end, 4. So we do 1 over 4 minus 0 times the integral from 0 to 4 of c of t dt. And this is a calculator FRQ, so we just used our calculator. We got 2.778. Then for b, find the time t when the instantaneous rate of change of c equals the average rate of change of c. Instantaneous rate of change is equaling the average rate of change. That sounds like the mean value theorem, which is f prime of c equals f of b minus f of a over b minus a. And then we just plugged in a, f of a, b, and f of b, and we solved for x using all of this algebra here. C asked us to write a limit expression that describes the end behavior of the rate of change in the number of acres. Oh, I misread this. Okay, no, you know what, we'll redo this one. C. The limit, assume that the invasive species continues to spread according to the given model for all times t is greater than 0. That is infinity. So we're writing a limit expression as t approaches infinity. And it's the rate of change in the number of acres. This shows us the number of acres. This is the rate of change. So we would just write 38 over 25 plus t squared. We can use our graph to solve this, graph it. And if we look, the graph looks something like, that's a very messed up graph. Our graph looks something like this, and it does not cross 0. So this is equal to 0 as t approaches infinity. Then counter the spread of the species function a defined by a of t equals c of t minus integral 4 to t 0.1 times natural log of x dx. Models the number of acres affected by the species over the interval 4 is less than or equal to t, which is less than or equal to 36. At what time t is from 4 to 36 does a attain its maximum value? Maximum value, we want to find critical points and our endpoints. So then, critical point, find the derivative. And we want to find possible maximum, maybe. So then, you find a derivative. A prime of t equals c prime of t, obviously because it's just c of t, c prime of t, minus, and then we get this because of the fundamental theorem of calculus, which says that the integral of derivative dx of this, and let's just say it's 0 to x, and let's just use c of t, says that these can cancel, so then it's going to be this, the inside, and then you can't forget that you have to take the derivative of the bounds. Derivative of x with respect to x is just 1, so this is just times 1, and minus c of t times the derivative of the bottom. The derivative of 0 is just 0, so then you just get c of t. And that's how we got 0.1 ln of x and then you just solve for when they're equal. I used a graph. I got this number. So you plug in. I found this wasn't a max, but then it's still a critical point, so you just solve for all your values. I didn't solve correctly here, but you just solve for them. You would get this according to the scoring guide that I'm looking at, but, or no, that's a lie. You would get this, but yeah. Okay, so now we can move on to the second one. The shaded region R is bounded by the graph of the functions f and g, where f of x is equal to x squared minus 2x, and g of x is equal to x plus sine of pi x, as shown in the figure. So this bottom one is f of x, and this top one is g of x. Find the area of R. To find the area of this little plane here, do the integral from the intersection points, and you do top minus bottom. So it intersects here at 0, and you can tell because when you plug 0 in for x to both equations, you just get 0. 0 minus 0 is 0. 0 plus sine of 0 is 0 plus 0, which is 0. So 0 is your bottom bound. And it says here this intersection point is 3. And we're going this way. Because we're going down, we do it in terms of x. So we want a dx at the end here. And we just do the top function minus the bottom function. The top function is g of x. And the bottom function is f of x. So this is our integral, and then since this is a calculator problem, we just use our calculator. Minus 2x. I'm just inputting my equations into my calculator into my y page because it makes my life so much easier. Pi x. Okay, so now we do Math 9, the integral from 0 to 3 of the top function minus the bottom function, dx. That would give us 0.637. That's our final answer. B. Region R is the base of a solid. For this solid at each x, the cross-section perpendicular to the x-axis, so this way, is a rectangle with height x and base in region R. Find the volume of the solid, show the setup for your calculations. Okay, so cross sections. I'm gonna try my best to draw what this would look like, kind of, but we're not gonna talk about it. And then go like here, like this, and then we have these going down. Then we have rectangles. It's something. It's something. But anyways, the point is, we have to find out what's the volume, and we're going to use an integral for this. And since we're changing in terms of x, we want everything in terms of x. So we do our intersections of x, so 0 and 3, as was in the last one. And then we do it's in terms of dx. Since it's rectangles, we want to think about the area of the rectangles. So the area of a rectangle is equal to base times height. We were told that the height is x. So it's really just h equals x. Now we need to find out what b is. And b is region R. So it's like this distance right here. So what we would do to find this region is we do the top minus the bottom, like we did here. So we do the top function minus the bottom function, which is g of x minus f of x. So we have everything. Our area is really just x times g of x minus f of x. You plug that in here. X g of x minus f of x. And we just solve. And when we do that, do x times y1 Why am I getting a negative answer? X squared minus 2x. How peculiar. That means my previous answer was wrong as well. Oh well, we'll just redo it. Let's do this one again. Okay, there we go. We get 7.705. That's our final answer. And our recalculated answer for the previous one, this is not This is neat how it'll do that. Oh well. I'm just gonna. Okay. This one is actually 5.137. My apologies. C. Write but do not evaluate the integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals -2. So we have this. I'm gonna draw this in a different color, and we're mirroring it. We're drawing the little volume, the little donut looking thingy with this. So what we would do is we're doing an integral because we're finding area under a curve. So then again we're doing R, so it's with respect to x, since we're rotating. I like to think of it as where like things are changing, like where the volume or like the line here is changing. So it's an x, so we put everything in terms of x. R is from 0 to 3. And then we do the top function minus the bottom function, because the top gives us, like, I like to think of it as the top gives us the total area, and because the bottom function is not touching where we're rotating about, there's a hole and that's what we're subtracting. So we're subtracting this little line from here to there. So let me just summarize what I said. We're finding the area from here, from the top function to the line, and we're subtracting it from the bottom function to the line. And that'll give us like our donut, as I drew here. And that donut just goes across from 0 to 3. So then we do 0 to 3, and then we do the top function, which is g of x minus -2, because that's our line. That's this distance to 0, then you go this extra distance right here, minus the bottom function f of x minus -2. This whole thing is squared multiplied by pi, because it's a circle. And then we don't have to evaluate this actually, because it said do not evaluate. So that's it. This is our answer. D. It can be shown that g prime of x equals 1 plus pi cosine of pi x. Find the value of x for 0 is less than x is less than 1, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Okay, so it's just asking when f prime is equal to g prime in the integral 0 to 1. I mean, not the integral, in the domain it's 0 to 1. So we just do the integral. So if f of x is equal to x squared minus 2x, f prime of x is equal to 2x minus 2. So we're just doing 2x minus 2 equals 1. 1 plus pi cosine pi times cosine pi x. We can just do our graph in Calc. Hello. Just put these two into your y and graph them. Why would we do any math if we have a graphing calculator? Hello. 2x minus 2 and 1 plus pi cosine pi x. Graph them. And find their intersection between 0 and 1. Okay, our x is equal to, you know what it is? 0.676. 0.67. Sorry. Anyways, that's where it is. That's our final answer. Yeah, pretty neat. Okay. Now we are going to move on to our third one, and we are entering no calculator parts of the exam, so now is the time you want to put away your calculator and solve these. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. Selected values of r of t are given in the table shown. At 0, 90 words per minute, 2, 100 words per minute, 8, 150 words per minute, 10, 162 words per minute. Approximate r prime of 1 using the average rate of change over the integral 0 to 2. Show the that leads to your answer indicate units of measure. Okay. R prime using the average rate of change. So we're gonna draw a line, right? Because pretend that this is the graph and this is 0, and this is 2. If we draw something like this, that's the line that crosses between 0, 90 and 2, 100. Our prime of 1 is going to be like right there. And that's what we want to find. So you just do f of b minus f of a over b minus a is equal to 100 minus 90 over 2 minus 0 is equal to 5, because 10 over 2 is equal to 5. And then we can just use this point right here, y 0, 90. So y minus 90 is equal to 5 times x. Now you plug in 1, y is equal to 5 times 1 plus 90 is equal to 95. And then you do words per minute. Words per minute squared. So I was just reading, I didn't read it thoroughly, but it's r prime of 1, but it's basically the same thing. If you look really closely and you squint, it kind of looks like a tangent line. It's the closest we're going to get. So that would be our answer, and we could check. I'm going to check right now. Make sure I do not accidentally peek. Yep, 5 words per minute, or 5 words per minute squared. Words per minute, minutes squared. Yep, okay. So I got that one right. Yeah, just think of it like this. If you squint really close, you'll see the tangent line. B. Must there be a value c for 0 is less than c is less than 10, such that r of c equals 155? Okay. This looks like the intermediate value theorem, because it's asking for the interval between, it's not the interval between 0 and 10. R of c is 155. Must there be? So it's asking, is this true? Like, does the theorem hold? And because there's no prime or anything, and there's an interval, and there is a number, I'm going to assume that this is talking about the intermediate value theorem, where it says that if f is continuous and differential, or not, just continuous. If f is continuous from A to B, A to B, it takes on all values from, excuse my handwriting, I'm on mouse, from f of A to f of B. So we must ask ourselves, is this continuous? And it is, because if it's differentiable, it's continuous. But we must state that because we're justifying our answer. So yes, it's continuous, so it must hold. And we ask ourselves, is 155 between 90 and 162? It is. So yes, there is an R of C that equals 155. Yes, R of C equals 155 in the interval 0 to 10 because R is differentiable, so therefore continuous. So the intermediate value theorem holds. 155 is between 90 and 162. So R of C equals 155 exists. C. Use a trapezoidal sum with the 3 subler intervals indicated in the data table to approximate the value of 0 to 10 RT dt. Show the work that... Okay. Trapezoid. We know that as the area of a trapezoid is equal to the height over 2, or like the width over 2, or something like that, times base plus height, where this is the width, this is the base, this is the, something like that, I don't know. So then we just plug in all these, like we do it from here, from here to here to here, and that'll give us our 3 trapezoids. So then we do the width of this is 2, so we do 2 over 2 times 90 plus 100 plus, then this is 6, so we do width is 6 over 2 times 100 plus 150 plus, this is a width of 2, so 2 over 2 times 150 plus 162. And this is an FRQ, so we can just leave our answer like this, which is awesome because I'm not using a calculator anymore, so I don't want to do this. Then D. A teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function w defined by w of t equals -3 over 10 t squared plus 8t plus 100, where w of t is measured in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? Show the work that leads to your answer. This just smells like an integral to me, because we have a rate function, because it's words per minute, and we're asking how many words has the teacher read by the end of 10 minutes. So we're asking for a total based on a rate function. It smells like an integral to me. So from 0 to 10 minutes, and we just do this function over here. 3 over 10 t squared. plus 8t plus 100 dt. So now we just have to evaluate this. Let me do that using the old anti-power rule, whatever. Plus 1 divided by, so then 2 plus 1 is 3 over 1, then you divide, so 3 over 10 divided by 3 is just 1 over 10 t cubed plus 1 plus 1 equals 2, 8 over 2 is 4, so 4t squared plus t, this is t to 0, so 0 plus 1 is 1, divided by 1, 100t, evaluated from 10 to 0. Then we have to evaluate this just a little bit more, so we just do 1 over 10 times 10 cubed plus 4 times 10 squared plus 100 times 10 minus 1 over 10 0 cubed plus 4 times 0 squared plus 100 times 0. 100 plus 400 plus 1,000 minus 0, 0, 0, it's just 0. 600 words. Okay. I am going to do one last one. I'm going to skip these two and head towards this one because it's the one I have space for. Consider the curve G defined by the equation y cubed minus y squared minus y plus 1/4 x squared equals 0. Show that dy dx is equal to negative x over... Okay, so we're just taking the derivative. So, power rule all this. You have to remember that there's a chain rule with the y, because we're deriving with respect to x. So we get 3y squared y prime minus 2y y prime minus y prime plus 1/2 x equals 0. So now minus 1/2 x to both sides. Yeah, I'm actually going to factor all this out. I'm going to factor out y prime in this step as well. So y prime is equal to 3y squared minus 2y minus 1 is equal to negative 1 over, or negative x over 2. Divide both sides by 3y squared minus 2y minus 1. And you get y prime equal to negative x times 2 times 3y squared minus 2y minus 1. And does that align? It does. Our final answer. B. There is a point P on the curve near to negative 1 with x coordinate 1.6. Use a line tangent to the curve at 2, negative 1 to it. Okay, so this sounds like the linearization thing. I forgot the name, but like you find the line tangent to the curve at some point x, and then you can use it to approximate the point at like P by using the line, the tangent line. So then we're going to use the tangent line at 2, negative 1. So y prime equals negative 2 over 2 times 3 times negative 1 squared minus 2 times negative 1 minus 1. That's equal to negative 2. Or actually, these will cancel, so this should be 1. So negative 1 over negative 1 squared is 1, 3, plus 2 minus 1, which is equal to negative 1 over 4. Note that this is our m, so m is equal to negative 1/4. Do we have our point? We do. 2, negative 1. So now we just draw y minus negative 1 equals negative 1 over 4 times x minus 2. Now, we just plug in 1.6 and then answer. So y plus 1 equals negative 1 over 4 times 1.6 minus 2. This would come out to y plus 1 equals negative 1 over 4 times negative 0.4. And then y plus 1 equals negative 1/4 times negative 0.4 is equal to negative 2 over 5. Which get 1 equals 2 over 20 minus 1. Y equals 1/10 minus 1. You can just leave it like that. So that's B. C is for x is greater than 0 and y is greater than 0. There is a point S on the curve G at which the line tangent to the curve at that point is vertical. So the y prime is undefined. Find the y coordinate of point S. Okay, so then this point on the curve G line. Okay, so we just have to find when y prime is undefined. So then we're going to use this here. It's undefined if the denominator is equal to 0. So we're going to do 2 over 3y squared minus 2y minus 1 is equal to 0. Divide both sides by 2. Yet 3y squared minus 2y minus 1 equals 0. You can factor this. This is negative 3. Adds to negative 2. Negative 3 and 1. Box. So we have 3y squared negative 1. This is negative 3y. This is y. So we have 3y and y. Then we have plus 1 minus 1. So 3y plus 1 times y minus 1. Y is equal to 1 or negative 1/3. But it said here that y is greater than 0. Y is greater than 0, so y is equal to 1. So then point S, y is equal to 1 at point S. D. That particle moves along the curve H defined by the equation 2x plus ln y equals 8. At that instant, when the particle is at 4, 1, dx dt equals 3. Find dy dt at that instant. Show the work there. What is this asking? How interesting. This is just weirdly worded. dy dt. Two xy plus ln y plus 8. When it's at 4, 1, 4, 8 plus ln 1. Yeah. What is this? This means you know what? We can find dy. We can find dy dx. dy dx for this one would be 2 times y plus xy pi plus 2xy prime plus 1 over y prime over y is equal to 0. And then y prime is equal to dy dx. So then we just solve for dy dx. Now I'm just going to do some shorthand because, so minus 2y 2x y prime is equal to 1 min plus y prime over y is equal to negative 2y. Take out the y prime, so you get 2x plus 1 over y is equal to negative 2y. So dy dx is equal to negative 2y over 2x plus 1 over y. What is dt? How peculiar. I'm just going to treat these as variables, and that's how I'm going to do this. I think it's good that I chose this one because this is an interesting one to do. It's very unconventional, and I don't know if I'm doing this right. But we're going to try things, and I'm going to look at that scoring guide later. Okay. So I'm going to solve for dx so I can get dt. So actually you have to solve for dy dx. Dx at 4, 1. So negative 2 times 1, right? 4, 1. Negative 2 times 1 times 2 times 4 plus 1 over 1 is equal to negative 2 over 5. Or no, 9. 2 over 9. So dy dx is equal to negative 2 over 9. Okay, so you got 9 dy is equal to negative 2 dx. And, oh, I know, you have dx over dt is equal to 3. So you get dx is equal to dt3. So dx is equal to 3 dt. So we do 9 dy is equal to negative 2 times 3 dt. So we get 9 dy is equal to negative 2, or negative 6 dt. Now we divide by 9 dt. Let's get dy dt is equal to negative 6 over 9, or negative 2 over 3. I'm going to check if that's right. Okay. So P differentiate 2x. Okay. No errors. Okay, so negative 2 over 3. What? Oh. Okay. So what it's telling us is to differentiate with terms of dt. Okay. So if you do that, I did do that. Okay. What's negative 2 and 9? Huh. Yeah, I did do that. Okay, so I did this right. So, if you ever see a problem that looks like this, just treat dy and dx as variables, or the other solution it gave was that you just differentiate in terms of dt. So you have like 2xy plus, was it, ln y is equal to 8. To differentiate in terms of dt. So like, this becomes 2 dx dt y plus dy dt times 2x plus 1 over y times dy dt equals 8. I mean 0, because you're still 0, it's a constant. And then you just solve for dy dt from here, plugging in everything, because you have dx dt, and you have the points. So, there's that too. It's neat. I didn't get through all of them, I missed 3. These are on College Board though, or I'll leave them up for you to like take a screenshot or whatever real quick. Alright, that's it. I'll catch you, and nice.